Hi there, Julie Russo here, creator of Structures of Equality, where we're making sense of math stories. If you're new to Structures, they're a reading comprehension tool that helps students better understand number stories. Before we get started, make sure you remember to subscribe to my channel below. I post weekly videos with actionable tips. Don't forget to ring the bell so you're notified when they're available. When I introduce parts equal total to teachers, they often ask me questions about the parts bars. They wonder if the size matters in relation to the total. And it's a nuanced answer. So if you have a story that describes decomposing 10 into 2 equal parts, this is what it would look like. You'd have 2 equal parts. But sometimes the story describes 10 being decomposed into 9 and 1. So this structure isn't precise. It doesn't go exactly with that story because we know 9 is much bigger than 1. So this is what I say to teachers when they ask me that question. The brain load that we're asking students to work through is pretty intense. So in the beginning, I really just want them to understand that the total bar can be decomposed into 2 parts, 9 and 1. I don't stay there very long though, however, because students quickly come to understand that this bar must, in fact, represent the value of that smaller part. When that happens, I switch my models and I go to this. So if a student says to me, the 10 in that story is being decomposed into 9 and 1, and that visual doesn't really make sense. Fantastic. Tell me more about that. Well, they might say, I know that 9 is a much bigger number than 1. So the part bar that represents the 9 has to be much bigger. So now, yes, absolutely. Tell me more about that. What's that look like? All those things we do as good teachers. So then I have a visual that looks more like this, and I'd have my labels on there, of course. And that shows me, yes, 9 is much bigger than 1. So I'm going to make that part bar significantly larger than this part bar. But initially, we're just talking about decomposing that total into 2 parts. Another great thing about using dry erase strips is sometimes we don't know what that missing part is. And if a student doesn't understand, doesn't have their math facts memorized, so then all of a sudden I have a story that says something about 3 red jelly beans and the rest were green. How many were green? So I have 3 here. All I've done is modeled this story. I don't know what this part is in that story. So once I've modeled this, I know it's a total being decomposed into 2 parts. Then once I solve, we can encourage the students to be more precise or nuanced with their drawing. So we have 7 jelly beans in this one. Wait a minute. What do I know about 7 and 3? 7 is a much larger number than 3. So the great thing about dry erase is I can move that part bar over to there, and I can see that my 10 is decomposed into the 3 that I knew, and then the part I had to figure out. And I could make that part bar 3 much smaller than the part bar of 7. So the answer to the question is, does the part bar size matter? Yes, sometimes, but initially in the beginning, we're really just wanting the students to understand that we can decompose numbers into 2 parts or even 3 parts. If you found this helpful, share it with a friend or check out the other videos I have available on my channel. For more free resources, join my email list and Facebook community. You can find the links below.